Hello friends, in this video today we're gonna solve this paper, mechanics and properties of matter, paper PHYC1 2024. Okay, Dibrugarh University, BSc-1st SEM. Okay, and this is part 1. So this paper will be completed in 4-5 videos. Okay, so I can't complete this paper in single video because the video will be too long. Okay, and if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAZIT 123. That's my Insta ID. You can follow me on Insta if you want. Okay, now let's start. Before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. Okay, so now let's start. So here is the first question. Choose the correct option. The art is a frame. The art frame is inertial, non-inertial, both inertial and none of the above. Which one is correct? The correct option is non-inertial. Okay, option 2 is the correct option. Okay, so what is the next? 1b. Question number 1b. For a non-conservative system, force is. So correct option is here none of this above. One answer is option 4, because you see negative gradient of potential. First option was negative gradient of potential function. That is for that is the condition for conservative force, not non-conservative. Okay, and positive gradient, it is also false. Then both negative and positive, that is also false, obviously. So fourth option is correct, none of this above. So now you see next 1c, this question. If omega is equal to 1 radian per second, then the relation between the moment of inertia and kinetic energy. We know that the relation between the moment of inertia and kinetic energy is nothing but E is equal to, kinetic energy is equal to half I omega square. And here omega is equal to 1 radian per second, 1 radian per second. So that's why E is equal to half I. If you put omega is equal to 1, which implies I is equal to 2 into E. So that's why correct option is this, option number 2. This is the correct answer, right? So hope you have understood this. Now let's say the next question. So here is the next question. Okay, here you see torsional couple per unit angular twist. So which one is the correct expression? This is the correct expression for this. C is equal to 1 by 2 I the r to the power 4. So this is the correct option. Okay, now 1e, the Poisson's ratio can't have we know that limiting value of Poisson's ratio, that is 0.5. okay, and that Poisson's ratio is less than this. So correct option should be 7. This cannot be the value of Poisson's ratio, right? This is greater than 0.5. So now let me answer question number 2a. Distinguish the inertial and non-inertial frame. So here is the answer. You see, this is the inertial frame. The frame with respect to which an unaccelerated body is unaccelerated, where Newton's first law is valid, and inertial is inertial frame of reference. Okay, so the frame of reference in which Newton's first law is valid is called inertial frame of reference. I will explain the meaning of these two statements. And definition of non-inertial frame of reference is the frame with which an unaccelerated body is accelerated is called an non-inertial frame of reference. Okay, and or you can say accelerated frames are called non-inertial frame. Let me explain this. Now you see, suppose you have two frames, this one and this is another frame, right? And suppose we have a body here at rest with respect to this frame S. Okay, so this is not accelerated. Okay, if you consider it is moving with constant velocity with respect to S, then also acceleration is 0. But for simplicity, let me consider this is at rest with respect to this frame, and this frame S dash is moving with a velocity, okay, or with variable velocity. That means it is an accelerated frame. Now you see this object is at rest, acceleration is 0 with respect to this, so that's why this must be also at rest. Okay, so that means there is no acceleration of this frame or this object with respect to each other, so that's why this frame will be called inertial frame. And on the other hand, this frame is accelerated frame, so that's why this object is accelerated with respect to this frame, so this will be called non-inertial frame. That's it. Okay, so now let's move on. So what is the next question here? Here you see, define stable equilibrium and unstable equilibrium. So I have already made a video on this, link is in the description box. I have written question number 2b and then I have provided the link in the description box. Okay, so now 2c, write the physical significance of moment of inertia. Let me give you the answer. Now you see, in case of rotational motion, in case of rotational motion, kinetic energy is given by E is equal to half I omega square, where I is moment of inertia, and omega is the angular velocity, right? And in case of translational motion, kinetic energy of a particle of mass m moving with velocity v is given by kinetic energy is given by half mv square. Now if we compare these two equations, here it is angular velocity, here it is linear velocity, and here is moment of inertia, and here is the mass. That means from these two equations, from 1 and 2, we can say that we can say that moment of inertia in rotational motion, moment of inertia plays the same role as mass does in translational motion. Okay, so this is the physical significance of moment of inertia, right? But as 2 marks is given, so we must give this explanation. Okay, only for this sentence you can't get 2 marks. Okay, just hope you have understood this. Now the next question is 2d, define power, dissipation and quality factor. Okay, so let me give you the answer. So here is the answer to this question 2d. Okay, just take the screenshot. Okay, now let me answer the next question. So answer to next question, that is 2e. So let me give you the answer. Okay, so here is the answer to 2e. Okay, and this is the Coriolis force. Okay, so take the screenshot. Now 2f, postulates of special theory of relativity. I have already made a video on this, so link is in the description box. I have written 2f and link is provided there. Okay, so hope you have understood this. In the next video we're gonna start from question number 3a. Okay, so stay connected. See you in the next video. Bye bye.